Hello, and thank you for watching this video in which we provide you with details and demonstrations for the release of AVEVA Telemetry Server version 2020. This is the second release of AVEVA Telemetry Server, which is a collection of protocols designed to support connectivity across geographically distributed SCADA systems. Generally, these are systems that operate with minimal resources and transmit data over extended distances and in intermittent or unreliable communication environments. AVEVA Telemetry Server precisely meets the needs of these low-resource, low-bandwidth conditions. Examples of industry verticals that are often geographically distributed include power distribution, water and wastewater, the two of which can combine as the foundation for our smart cities, and oil and gas. Prior to this release, AVEVA Telemetry Server supported the Modbus and the DMP3 protocols, but with version 2020, we have added support for the IEC 6870 Part 5 protocol. Let's review the features of this release. First, AVEVA Telemetry Server supports both 6870 Part 5-101 for data transmission over serial connections and Part 5-104 for data transmission over TCP/IP connections. Once connected, users of IEC 6870 Part 5 can take advantage of master-slave implementation, both between nodes and within a single node. Also, there are a variety of polling options, high availability through dual and triple redundancy configurations, and a reduction in engineering time through the use of templates and instances and the export and import of established configurations. Whether your geographically distributed system will have a single centralized master station or a master station with multiple regional hubs, Telemetry Server 2020 with support for IEC 6870 Part 5 can work for you. When ready to install, simply select Install Telemetry Server Comms Drivers and follow install instructions. Are you new to configuration of telemetry server protocols? No problem. As with the DMP3 and Modbus protocols, Telemetry Server 2020 offers pre-made IEC 6870 Part 5 templates for common architectures to help users realize maximum value in the shortest amount of time. Now let's deploy an application server user-defined object to demonstrate connectivity via IEC 6870 Part 5. Once connected, you can view the data points and check their status in the Telemetry Server configurator. You can also verify that data acquisition is successful in Application Server Object Viewer, which will show you the value and the value quality for each data point. Here we can see data ingress with good quality. In this last demonstration, let's look at failover and buffered data backfill capability for Telemetry Server 2020 with support for IEC 6870 Part 5. Two telemetry servers have been configured, one to act as the primary server and one to act as the backup server. In the primary server, we can see that data is being collected for a Boolean tag, an integer tag, and a real tag. A quick check on the status of the integer and real points indicates that data acquisition is successful. On switching to Object Viewer, we can further verify data ingress for these three tags and see that the quality of the data is good. Finally, a historian client trend has been set up for the numeric values and is currently displaying rising values for the real tag. Now let's switch back to view the primary telemetry server. The server is being shut down to force a failover to the backup server. Looking back on the trend, we can see that the rising value is now showing flat as data has stopped being received. Returning to Object Viewer, we can also see that the quality of all values has momentarily turned to bad quality. But as the backup server comes up, data starts coming back in and the quality returns to good quality. Finally, on viewing the trend for the real tag, we can see that it has resumed rising and that data that was buffered during the failover process has backfilled the trend line. And that concludes this video introducing AVEVA Telemetry Server 2020